Hello everybody, my name is T. Anand Mukesh and I'm going to explain why Mangalyaan underwent a series of orbit-raising maneuvers before it was launched towards the Mars. Mangalyaan's trajectory was divided into three phases. The first phase is the geocentric phase, which was bounded towards the Earth, and the second phase was the heliocentric phase, which was bounded towards the Sun, and the third phase was the Martian phase, which was bounded towards the Mars. And these series of orbit raising maneuvers were performed in the geocentric phase, means under the influence of the Earth. Any spacecraft in space will undergo an orbit of an conic, simply because in a conic the energy is conserved at each and every point in the orbit. Now consider a circular and elliptical orbit. In the circular orbit, if you see, the total energy is same at every point, and also the potential energy and the kinetic energy is same at each and every point. But in an elliptical orbit, the total energy remains same at each and every point, but the amount of potential energy and kinetic energy is not same at every point, because if you see, the potential energy is highest at the farthest point, and it is minimum at the lowest point. And there are mainly two points in an elliptical orbit, the apogee and the perigee. Perigee is a point which is very nearer to the Earth, and the apogee is a point which is very farther from the Earth. And we can observe from this formula that velocity is inversely proportional to the distance. So at the perigee, it will have the highest velocity, and the apogee will have the lowest velocity because of the distance. This is the trajectory in which these earthbound maneuvers were performed for Mangalyaan. And if you see, when the PSLV launched the Mangalyaan, it was placed in a elliptical parking orbit with a much lower velocity. And that velocity was not enough for the Mangalyaan to escape the Earth's sphere of influence. To escape the Earth's sphere of influence, we need the external boost, and this extra boost was provided by these orbital maneuvers. And there were six main engine burns that were performed at the perigee using an LAM, which stands for liquid apogee motor, which means at each and every burn, the apogee of the spacecraft increases. Thereby, a velocity at the perigee gradually increases after each and every burn. So, thereby, at the end of the last burn, the spacecraft gained enough velocity to escape the sphere of influence of the Earth. And this methodology of increasing the velocity could have been prevented by using a powerful launch vehicle, or by increasing the engine capacity of the spacecraft. But if you increase the propellant capacity in the launch spacecraft, the cost of the launching will increase. Thereby, the complexity also increases. To reduce the budget of the mission, this smart orbit raising maneuvers were performed, thereby it achieving the a required velocity to escape the Earth's sphere of influence. Thank you.